Solution to problem 8, example 8. The 180-pound force is applied at point A of the bracket. Determine the moments of this force about point B and about point C. So let's use the right thumb rule here, the scalar approach. So first, let's resolve the 180-pound force into its components. The horizontal is going to the left, acting at A. So it is 180 cosine of 60. So it is 90 pounds leftward. Then, because we are given this slanted distance 15 inches and the angle here with the vertical is 45, so the vertical component of distance and the horizontal component of distance will be equal. And each is 15, the vertical is 15 cosine 45, and that is equal to 7.5 square root of 2. So the horizontal is 15 sine of 45, the same as 15 cosine 45, 7.5 square root of 2 inches. Then the force is resolved into its components. So 180 times cosine 60 is 90 leftward, and 180 sine of 60 is 90 square root of 3 pounds downward. So that we can analyze the moment arms of these components of force. So first, because we solve this by scalar approach, so we consider dx summation moment about dx axis. So by right thumb rule, the direction of positive movement should be going in that direction. So the right thumb is positioning towards the positive x-axis. So your forefingers will be curling in this manner, so that the 90-pound force has no moment because it is parallel to dx, only the 90 square root of 3-pound force. And because the moment of this 90 square root of 3-pound force is opposing this positive direction of moment for moment dx, so it is negative. The distance between this axis here and the x-axis through A is equal to 12 inches. I hope you can visualize the distance between bx and ax. So it is this distance here, 12 inches. So it is negative 90 square root of 3 times 12. So that's moment dx. So mbx is negative 90 square root of 3 times 12. In decimal form, it is negative 1870.6 pound inches. Next, about dy. Y is the vertical axis, so that's the dy axis. Again, position your right thumb towards the positive y axis. Your forefingers will curl in that manner. So the positive moment about y-axis through B is in that direction. So we ignore 90 square root of 3 pounds because it is parallel to the by axis. So forces parallel to an axis will have no moment about that axis. So only 90-pound force is producing moment about dy. So this 90-pound force will have a distance. If you extend this dy axis here, the distance is again 12 inches. I hope you can visualize it, and it is positive. So try to curl your forefingers. The 90-pound force will rotate in that manner. So same as that rotation there. So therefore, the moment of the 90-pound force would be positive. And it is 90. The moment arm is 12 again. So 90 times 12. Mby equals 90 times 12. So it is 1,080 pound inches. Then finally, moment about dz axis. So the positive z direction is forward. That's it. Position your right thumb towards the positive z axis, and the curling of your forefingers, which is the positive moment, would be that direction there, same as that. So both these components of forces will have moment about the z-axis. So, and the 90-pound force is opposing that positive direction of moment. So, it is like that. So, it's negative. And the 90 square root of 3-pound force is also rotating about the BZ axis in the opposite direction as this. So both are negative. So therefore, moment about BZ axis is equal to negative 90. The moment arm of negative 90 is equal to this vertical distance here, which is 13 plus 7.5 square root of 2. While the moment arm of 90 square root of 3 is, so this is the projection, is equal to this distance here. So imagine this is also the z-axis. So the distance between this line and that line there is equal to 7.5 square root of 2. So MBZ is negative 90 times 13 plus 7.5 square root of 2, then negative 90 square root of 3 times quantity 7.5 square root of 2. So computing, MBZ is negative 3,778 pound-inch. Therefore, in vector form, the moment about B is negative 1,871 I, then positive 1,080 J, then negative 3,778 K pound-inches. So that would be the moment about point B in vector form. So remember, this is the x component of moment about B, the y component of moment about B, and the z component of moment about C. Now let's proceed to point C. So if you rotate the figure, so you change orientation so that we'll see, or you position yourself about, position yourselves on the positive z-axis, and because this is only 6 inches, which is shorter than this 7.5 square root of 2, so this 90 square root of 3 component of force, which is downward, is rightward, right side of C. So that first moment about CX, so we draw a line parallel to CX, position your your right thumb towards the positive CX axis, then curl it. So the positive direction of moment about C is in this direction. So because point A, this point here, this edge and this edge here, including C, lie on the XY plane. So therefore, the 90 square root of 3-pound force has no moment arm, or it crosses the CX axis. So it has no moment about CX because it passes through CX. So I hope that you can imagine that this corner here, this edge, that edge lie on the plane which is XY plane. So there's no Z distance because the moment arm should be delta Z supposedly. So only 90-pound force. Secondly, the 90-pound force is parallel, therefore moment about CX is 0. Next, CY. So the 90 square root of 3-pound force is ignored. So we draw CY first, then the positive moment would be the same as this. Position your right thumb towards the CY, positive CY axis. So this will be the curling of your forefingers. So that's the positive direction of moment. So the 90 square root of 3-pound force is parallel to CY, so it will not produce moment. Then because the 90-pound force acts at A and C lie on the same plane, which is XY plane, so there will, if we extend CY downward, in other words, the 90-pound force will cross the extension of the CY axis. So the moment arm is 0, therefore there's no moment also about CY axis. So MCY is 0. Then finally, moment about CZ, so we draw the positive CZ axis, then the positive direction of moment would be the same as this, just like Bx, but of different point. So position your right thumb towards the positive ZZ axis, then this will be the curling of your four fingers. So therefore, that's the positive direction of moment. So because the 90-pound force will rotate about the CZ axis and it will oppose this direction of moment. So 90-pound force will produce negative moment. Same is true with 90 square root of 3 because if you extend 90 square root of 3, so it lies to the right of this edge here, CZ axis, so it's also opposing that moment. So what is important is the moment arm. For the 90-pound force, the moment arm would be this total vertical distance because this is horizontal and this is also a horizontal axis. So the vertical distance between them is 13 plus 7.5 square root of 2 and the moment produced is negative. For 90 square root of 3, it's also negative and the distance is the difference between 7.5 square root of 2 and 6 inches. So this is 6 inches if you draw a vertical line. So the net distance or moment arm of this 90 square root of 3 would be 7.5 square root of 2 minus 6. So moment about CZ axis is negative 90 times 13 plus 7.5 square root of 2, then negative 90 square root of 3 times quantity 7.5 square root of 2 minus 6 inches. So MCZ is equal to negative 2,842.7 pound inch. So in vector form, MCZ is negative 2843 pound inch K. 2840 pound inches. So those are the answers to this problem. Then another way you might find this easy than this, but this is the solution where you will gain understanding of moment of a force in space. Because this is highly mathematical, the second solution is by vector approach. So the force in vector form is negative 90I because it is opposing the positive x-axis, then negative 90 square root of 3j. Then because moment about point B is simply position vector from the point to any point on the line of action of the force. So there's only one point on the line of action of the force, which is point A. So we defined vector position vector RBA. So if we describe RBA in vector form, it is to reach point A. So we have to go down by 13 plus 7.5 square root of 2. That's parallel to the y-axis. So negative 13 minus 7.5 square root of 2. Then to the right, that this is parallel to x direction. So 7.5 square root of 2i. Then backward. So that's along z. So negative 12. See, so in vector form, the components of distance for RBA would be positive 7.5 square root of 2i, then negative quantity 13 plus 7.5 square root of 2, it's quantity, so negative quantity 13 plus 7.5 square root of 2j, then this is also opposing the positive z direction, so negative 12k. So moment B is RBA cross F, and there's only one equation. That's the only equation. So MB is equal to, this is RBA. So the components of RBA would be, as mentioned earlier, along x 7.5 square root of 2, along y negative quantity 13 plus 7.5 square root of 2, then along z is negative 12. Then for the next row, copy the components of force, which are negative 90 and negative 90 square root of 3. The z component is 0. Then write ijk here. Then by basket method in computing determinants of a matrix, and you experience this, you have to copy the elements in the first two columns, which are this. Then just like computing determinant, so you have to multiply this. So we'll begin with I. So this is definitely 0 because of this part. So you have to multiply this value with this 0. So that's 0. And minus that direction. And this direction is minus of the product of negative values is positive. So negative of positive is negative. So if you notice, moment about B would be the same. We have here for MBX negative 90 square root of 3 times 12, because the product is positive and this is the negative direction, so the result is negative. So it's the same. Then for MBZ, so along for the J component, we have 12 times negative 12 times 90, so it is positive. Where is that? This is it. 12 times 90 or 90 times 12. Then 0 times 7.5 square root of 2 is 0. So we only have 90 times 12, which is equal to 1080. Then along Z or K, we have negative 90 square root of 3 times 7.5 square root of 2, which is this. Which is 90 square root of 3 times 7.5 square root of 2, which is this, right? It's negative. Then minus, so the product of these two is positive. So minus, the product is positive. So minus 90 times quantity 13 plus 7.5 square root of 2, which is this. So it's the same. So the result would be the same as MB, which is negative 1071I plus 1080J minus 3778K pound. Finally, for C, so we have to define moment about C is RCA cross F. Now, RCA as a vector, remember that C and A lie on the same plane. So, and A is right of C. So that net distance, you have to move to the right by 7.5 square root of 2 minus 6 along the x-axis, then go down. Then we reach point A. There's no movement along the z-axis, so there's no component along z-axis for CA. So it is simply quantity 7.5 minus 7.5 square root of 2 minus 6i, this is this. Then negative quantity 13 plus 7.5 square root of 2. There's no z component of distance for CA. Then components of force. Then perform the same approach as here. So going down, positive. So let's begin with I. So this is 0. Can you see? 0 times this value is 0. Then minus that value. I negative 90 square root of 3 times 0. So it is also 0. That's why MCX is 0. CX is 0. MCY. So 0 times negative 90 times J is 0. Then minus along this diagonal, 0 times quantity 7.5 square root of minus 6 is also 0. That's why MCY is also 0. And finally, for the C component of moment about C, so we have here negative 90 square root of 3 times this moment arm. Can we see that? Negative 90 times square root of 3 times this moment arm, which is this. It's the same. And negative. Then in that direction, so that's the first. In that direction, we have Negative of negative 90 times negative, so that's negative. Negative 90 times quantity 13 plus 7.5 square root of 2, which is the same as that. So therefore, the answer for moment at C is the same in vector form. Negative 2843 pound inches. And that's the final answer. I hope that you got the point.